every type of question, there are some ways to play the game. So here, when you do a question, there are always three derivatives that you try to create. Right? So the spherical balloon is being filled with helium. Surface area is increasing at a rate of 8 cm square per second. 8 cm square. So what derivative does this represent? Okay, it's a dA dt. dA dt should be equals to 8 cm square per second. Because they say that the surface area is increasing at the rate. So far, okay? So after that, they ask you, what is how fast is the volume changing? How fast is the volume changing? So what are they asking for? Which derivative are they asking for? They give you this. They're asking for none other than how fast the volume. How fast? Volume. How fast? How fast refers to time. Volume. So it's dV dt. Right? dV dt. Oh. So from here, then okay. This is a type of order. Okay, so I know that I'm given dA dt, right? The strategies are there are two steps. There are two steps. So I'm given dA dt. I'm given dA dt. The one that gets me the marks is dV dt. Okay, you notice I wrote them on two different columns. Why? Is because I'm going to do on the left side first. I'm going to go on the left side first. Given, I'm going to find the one the marks here is dR dt. And the one that's finding will be dA dr. Okay? So from dA dr, I'm going to do this on the left. The reason is because I want to find dR dt first so that I can plug my dr here. Okay, so that here the one that's hiding is dV dr. Is that okay? Is that okay? So most of you who got stuck at this question, let's quick check. So my guess is if I were you, right, then why would I get stuck? Because I'll be writing this up. So I'll be writing this is given, right? Then the one that gets me the marks is supposedly dV dt, right? So I'll be thinking that the one that's hiding could be dV dA, right? Could be dV dA, right? So then you'll be dV dA. How do I find dV dA? Is there a V in terms of A? So this is one thing that will bother you, right? So one way is I break it up into two parts. Okay, I can find my dR dt first, then I find I sum it, or then there's another way. Yeah. Oh, okay, this part. So this is the part that most of you will be jammed at, right? You'll be stuck here, right? So what I want to sell to you is, okay, show you all see. Treat every derivative like a fraction. This is like dV dr multiplied by dR dA. Okay? Sell to you. Sell to you. dR dA, usually we don't have dR dA now, we have dV dr 1 over dA dr. Oh. And dV dr means we differentiate V with respect to R, we differentiate A with respect to R. Okay? dV dr. So what is V? Remember we are talking about a spherical balloon. We are talking about a spherical balloon. So which means that your V is 4 over 3 pi r cubed. dV dr is just 4 pi r squared. Because we use the word spherical. Okay, then area for a sphere again is 4 pi r squared. dA dr is equals to 8 pi r. Now we have the function ready, we just need to know what value to put in. The radius is 5. The radius is 5. So when the radius is 5, all I do is I sub my R as 5. DBDR will be equals to 4 pi of 5 square, which is 100 pi. DADR will be 8 pi of 5, which is 40 pi. Okay, so DBDR, DADR, with this, so start it here, that's here. This is 100 pi times 1 over 40 pi, which is just 5 over 2. And this is just a ratio, just a ratio. Okay, so you see, I have my DBDA already. So those who are stuck, I hope you got past the jam now. Got past the jam. So with this, right, 5 over 2, so you notice how I planted then here, planted then here. So the next part, I just need to use this one. DBDT, the one that gives me the marks, the one that they are asking for all this while, is the same as DBDA, which is 5 over 2. DBDA, which is 5 over 2, times DADT, which is 8. So the answer just turned out to be 40 over 2 or 20 cm cube per second. Because we are changing volume with respect to the time, so it's cm cube per second. Okay, changing volume with respect to time, therefore it's cm cube per second. Okay. So yeah, this way my work out. Can it's possible. You will still get the answer. You should be able to get. It's very tedious. So I mean, you may have done something like this. Like volume is 4 over 3 pi r cube. Area is 4 pi r square. So you can do this. Area over 4 pi square root. That's your r, right? Right. Is that what it is? No. Correct. And which is what I'm doing also. We did again R. Oh, then because your volume in terms of A, right? Then you cannot have R inside. Because R is a variable. If you are doing what you are doing, right? Let me show you what I will do if I use your method is I use A, I make R in terms of A, right? Then I sub A here. 4 over 3 pi of A 4 over pi cube. So this is your B in terms of A. Okay, so then now if you are going to find DBDA, you realize that you are at a big disadvantage because it's so disgusting. Okay, so don't need to try to find DBDA. Right, you can actually split it into 2 marks. Just like eating, you don't have to always eat the burger and fries together. Eat the burger, then take the fries. No? So DBDR, nice number. DADR, nice number. Okay? That is for question 9. That's for question 9. Today you stretch a bit. I think practice set 2 is going to take the whole lesson. So you might be listening to it. Question 14, what's for this? You want to go through this? You want to know? Okay. This one, is it okay? Is it okay? Can I erase? Or you didn't take photo or anything? Erase. Okay, extreme. This question also very fun. So the way to play the game, you will realize by now is always find the three derivative, find the three derivative. Yeah. So the man who is 2 meters tall, walking away from the street lamp. So he's walking away at the rate of 5/3 meter per second. So it's like if this is walking away, right? This is like trying to tell us that which derivative would this give us? Anyone can make a guess? The guy who's walking away. Is walking away. So this is like the distance between the man and the lamppost, which is y. And I'm walking away at a rate of 5 meters per second. Correct, dy over dt, very good. So dy over dt is 5/3. Now given that the top of the man shadow is x meters from the, so the top of the man shadow is coming here. So you see, imagine I shine the light, so this man, the top of the shadow is here. So it's like if I shine the light, the top of the shadow is here. So this is where this particular point here, this is where the top of the shadow is now. Okay, then this distance is x meters. Is x meters. Okay, I express y in terms of x. So how do I do this question? Anyone can tell me? How do I do this question? I give you all a hint. Look at this and look at this. Those who did this question, mention 90 equals 40. Mention 90. Who can tell me the topic? You use this when you did codes. You use this when you did pyramid. Who said that? Who said that? Yeah, correct. Similar triangle. Similar triangle. What is it? What is it? Mensuration. 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 It's so correct. So it's like you can see if I use the blue triangle, 2 over 7 is as same as x minus y or x minus y over x. Okay, so using similar triangles. Sorry? Sounds easy. X over 2 over 7 is the same as x minus y over x. So this distance here is x minus y. Don't need to prove. Don't need to prove. You just write down using similar triangles. That's good enough. Don't need to write what SAS, AA, that kind of thing. You don't need to do that. Using similar triangles. So far, okay? Okay. Sharon can see. Okay, I'll transfer to the board in case it gets pushed. So the 2 over 7 is equals to x minus y over x. So So what do they need? They need x in terms of y, right? They need y in terms of x. So okay lah, not so bad now. So 2x equals to 7 times x minus y. 2x equals to 7x minus 7y. 7y equals to 5x, and y is 5 over 7. Okay, let's see the same one. If you see overlapping triangles, it's slightly similar triangles. Yeah, and I want to also remind you that this is a very popular topic. Yeah, find the rate at which the top of the man's shadow is moving. So which derivative are they asking for? Find the rate at which the top is moving. The x, correct. They want the x dt. Right, because the top of the shadow is x, right? This is the top of the shadow, right? The top of the shadow is x, right? Find the rate is they're asking for dx dt. So they need dx dt. The one that gets me the marks is dx dt. Which one is given? I want to ask which one is given. So I'm going to ask one of you. Shikai, give me a hint. Good. Just name. Sorry? Wait, come. Which one is given? Which one is given? I give a hint. dy dt, right? dy dt, so you are given that dy dt is equals to 5 over 3. So last one, which is the one that's hiding under the bed? Give me another name. Cheryl. Okay, Cheryl. So what's the one that's hidden? See, this one is given, this one is the mask, which is the one that's hidden. Just see the variable. He already appeared 2 times. Yes, dy usually is usually dy dx. Okay, so when it's hidden dy dx, you need y as a function of x, right? So you need y in terms of x, right? Do you have y in terms of x? Yes, right? So you also be very grateful that they asked us to do part 1. Precisely why they asked us to do part 1. This is to allow us to find dy dx. Here, it's here dy dx is just 5 over 7. It's a constant. So dx dt is just equals to dy dt multiplied by 1 over dy dx, which is 5 over 3 multiplied by 1 over 5 over 7. It's 7 over 3. So this is up. Okay. You will make sure you understand first before you copy. Take as much time as you need. Make sure you copy what makes sense to you. Copy your notes as though you are signing a contract. But still moving on back now, also on your now. Okay. Ready, okay. All okay with this question? Okay, now this one is question 1. Okay, this one is this is the one. This question 5. Go to question 2 first. Okay, question 2. Who watched the video for this? Are you able to understand? Okay, so I'll just say the same thing. Yeah. So you raise up, It's also set by okay, so this is 5 cm. This 5 cm. Okay. Okay. So let's appreciate the question again. Once I see the word rate, I know that they are asking for rate of change. They are asking for rate of change. Okay, so I'll look at this and let's read the question. Usually one of the derivatives is given. So maybe I want to ask Hayden, which derivative is given? Which derivative is given? The angle theta increases at a rate of alpha radian per second. Correct. So you are given that d over dt is equals to alpha radian per second. I mean, this is the unit for angles. These angles are it's just a radian volts. Okay, angle per second. So this is d. So we are referring to this theta here, right? It is moving at alpha radian per second. 1 second alpha, 2 alpha, 3 alpha, 4 alpha. It's moving at this. That's how much. How the angle is changing with respect to time. Okay. So next one, find the rate of change of the area of the minor segment ACB. They are referring to this. Okay, this is the segment that we support. Okay, so what's the one that gives us the marks? Find the rate of change of the area. Give me another name. Sorry? That's a noun. Okay, that's a noun. So find the rate of change of the area. Which derivative do you want? Find the rate of change of the area. Sorry. Correct. So I want to find ACB. I want to find ACB. So what is the one that's hiding? Nathaniel, give me another name. Joshua. Okay, Joshua. What is the last one that you need? Very good. DA over deleted. Okay? Which if you know that you need to do DA deleted, you need A in terms of theta. Am I right? Okay, so this is where the journey begins. We need A in terms of theta. Yeah? So you notice that in every question in practice set 2, I always start with the 3 derivatives. Okay, so you begin with the n in mind. When you have the 3 derivatives, this will fixate you in the right direction. Okay, so A in terms of theta. What is my A? Area of segment. Area of segment in case you don't know. Half r squared theta. This is sector minus the triangle. Half AB sine C. So the area of the segment by right is half r squared theta minus half AB sine C. Are you okay with this? Are you okay with this? Okay, if you are not okay, it's just memory lah. Memory work. It's just formula list. This is the formula list. Okay. Is it okay? Yeah. So this is just the area of segment. Segment is this part. Segment is like the ice cream. The triangle here is the sector is the entire ice cream and the cone. Okay. So this segment here, half r squared theta minus the triangle, half AB sine C. I know that the radius is 5. The radius is 5. So it's 25 over 2 theta minus 25 over 2 sine C. because I sub R as 5. This is my A so far, A of the segment. Okay, right? Go crazy a bit. Okay, so dA d theta, because I did this one, right? What is it equals to? It's just 25. Differentiate theta will just be 25 over 1. If I differentiate with respect to theta, I treat theta as the variable, right? Then 25 over 2 theta just becomes 25 over 2. Okay, it's a linear, becomes constant. Then differentiate with respect to theta. If I differentiate sine, because differentiate sine, I will get cosine, right? So this is 25 over 2 cos theta. Okay? Can I? So then we know that this is the one that we are supposed to solve, and we ask ourselves, why so? What's the third I need to find? How do I start the third? Okay. So we need to know. We need to evaluate cosine theta. So what is cosine theta? Now the numerical proof that it gives us is that the area of the triangle is 7.5. Okay, the area of the triangle is 7.5. The area of triangle OAB, which is 7.5, right, is also equals to, this 7.5 is equals to half AB sine theta. It's also equals to half AB sine theta. 7.5 here, which is the area, is 25 over 2 sine theta. Now sine theta is equals to, what's 7.5 divided by 25 over 2? Is it 3 over 5? 3 over 5? 3 over 5? 3 over 5? Yeah. So I'm given sine theta. Then, how do I evaluate cosine theta? Correct, very good triangle thing. So you must remember the big picture. Why is it I need the cosine? So actually at home I have a whiteboard. Sometimes I do math, I find it very, I go to the whiteboard this year. Also, I can see the big picture. This is very nice. So sine theta is 3 over 5, right? I need this to evaluate cosine theta. Because I need cosine theta for dA theta. So, if sine theta is 3 over 5, just imagine, if theta here, let's say I just use theta 3 over 5. Okay, so can I say that sine alpha also be 3 over 5? So this is alpha. So this will be 4s. Right angle triangle. So what will cosine alpha be if it will be 4 over 5? Okay. Now cosine alpha only, but you must note that cosine theta, it could be 4 over 5, or it can also be negative of 4 over 5. The reason is because they use the word minor. This theta could be obtuse. If it's obtuse, right? If theta is obtuse, aka you are looking at quadrant 2, then cosine theta is negative. If you are looking at acute, quadrant 1, then theta is positive. So far, I'll cover this part. This is the most disgusting part in the whole question. Other than that, everything else is routine. Find the 3 derivative, sub the value. This part is the most difficult part. Cosine theta is 4 over 5. Okay, so the final answer, you know that your dA dt, right, is supposed to be dA d theta times d theta dt, which is 25 over 2 minus 25 over 2 cos theta. Things like this. multiplied by alpha. Okay, so because cosine has two possible answers, this dA dt will have two possible answers. You will have two possible answers. Okay, so it could be 25/2 minus 25/2. Cosine theta could be 4/5 times alpha if theta is acute. Or it could be alpha 25/2 minus 25/2 if theta is acute. Okay, rather difficult. Is there any part that I lost you? Can I repeat for you again? Is there any part that I lost you? Because this question is very long. Once again, remember that in connected rate of change, the idea is to start with three derivatives. These three are always the first three to start with. This will anchor you in the right direction. Now, if you do these three properly, you know that the one that's hiding is dA d theta. Okay? Now, dA d theta is the one that's hiding. You have the formulas with you. You find dA d theta. In this step, you will find that you are now on a journey to look for cosine theta. Okay? So, what is cosine theta? Because the question gives you the area is 7.5. So, the area is 7.5. 7.5 is OAB. Half AB sine C. Half AB sine C. You find your sine. For the sine, you get two values of cosine. Then you bring back into the connected rate of change. Okay, ma? The most difficult part I would like to highlight is this one. That there are two cosine values. Very difficult. Very difficult. Also, really, our math has to be very sound. And also knowing the triple knowledge. Okay. Okay. For this question, do you really want me to go? Is it okay I ask you to watch the video? Is it okay? It's very long. It's then a bit high. It's a bit sick out. Okay, but actually, the whole time also up. Okay. Yeah. This question is quite challenging because there's a small r. You need to fix some. There are letters which are fixed. There are letters which are variables. Okay, so my advice is just go and watch the video. Okay. Even if you never submit this remotely, you didn't submit this question. Okay. Okay. So do I go to practice set 3 or shall I go back to the notes? Are you okay? I'll continue. Okay. I go to practice set 3. Yeah. Practice set 3, I believe I did a lot of the details also. So, is there any question that you want me to go through? Question 1 is this one. Erase? Anyone taking photo? Yeah. This is question 3. Which question is this? Sorry. 1. Any more? Practice set 3, 4 is together. Now, question 1, any more? 4. Monsieur, you see, do you have any question? Do you start? Y is equals to tangent AX. So y is equals to tangent AX. So this is quite fun because okay, if you see the y dash, right? The y dash refers to dy dx. Okay, so what you want to show is you want to show that your y prime is equal to a plus ay squared. What is y prime? So I mean, if I look at this, right, the first natural thing I want to do is my y prime, I just differentiate. Yeah, differentiating this. Differentiating tangent will give me, let me ask, let's stop just now. Because give me a name. Give me a minute. Give me a name. Go, give me a go. Okay. Differentiate tangent will be secant square. Also, this is secant square ax, right? Is this correct? Am I correct? Good. No. What is it there? Oh, okay, yeah. Okay, so this is y prime. So looking at this, I want to show that it's a plus ay squared. Okay, so you go to the right. What is a plus ay squared? A plus ay squared will look something like a plus a tangent square ax. Alright, you want this to look like this. You want this to look like this. Same or not? Same or not? They are actually the same. They are actually the same. You want this to look like this, right? You want this to look like this. So are they the same? Secant square and tangent square. Do you remember some your younger days? They actually have a relationship. Hang on. Secant square and tangent square. Easy. So you mean this. Related. Yeah, Pythagorean identity. Also, secant square is tangent square plus 1. Remember Pythagorean identity? Pythagorean identity. It's in your formula. It's your formula. Where secant square x is tangent square x plus 1. You remember this? So coming there, I mean, it's quite clear because I know that I'm using this is the same as a of tangent square ax plus 1, which is a tangent square ax. This is basically this my y, so it's just a plus ay squared. Very, very easy one. Very, very easy. Okay. The only thing if you are stuck at this question probably will be because like the question itself, okay, y prime, how come my dy is got y inside? That's the part that will bother you. But at the end of the day, it's just a substitution technique. Okay, you are just playing substitution, that's all. Okay. You do it in terms, you see what I did? I did in terms of x and then I just subtract the y. Okay, it's just a substitution thing, that's all. So now express y double prime. Similarly as polynomials in y. That might bother you, but again, I'm just going to do it in terms of x as well. So this is my y prime. I'm going to find y double prime in terms of x. A is a constant. I'll write this secant square as secant. The entire thing square. Outside is power 2. Outside, power 2. That's one layer here. This is one layer. The one layer is something to the power of 2. It's something to the power of 2. The second layer is the secant. Let's say second layer is the secant. The third layer is the ax. Also, this is layer 1. Layer 1 is that something to the power of 2. Layer 2 is secant power secant. Layer 3 So when I differentiate this, I use chain rule. Okay, differentiate chain 1. Layer 1, power goes in front, power drop by 1. Layer 2, differentiating secant, what should I get? I want to ask, who was, this one give me a name. Sorry? ANC, huh? Sorry? Yeah, okay, differentiate secant. Okay. Okay, you can nominate a helper. Yeah. Beatrice, okay, Beatrice. Differentiate secant. Secant tangent, right? Secant AX. Tangent AX now. Followed by layer 3, that will just leave me A. Right, just leave me A. Okay? So this is 2 secant AX. So if you see, once again, this is layer 1. This is layer 2. I know you are very good in chain rule already. I just want to revise a bit. This is layer 3. Okay? So you see secant square, tangent. A square, 2, that's 2A square, secant square AX, tangent AX. Okay? 2A square, secant square, tangent. 2A square. Secant square is what? Essentially, you see tangent square plus 1. Yeah. So if I write secant square in terms of y, what should it be? Also give me another name. Or maybe just give me another name. Sorry? Okay. If I express secant square in terms of y, what should it be? Wow. Very close. Secant square in terms of what? You going to tell me?
1 plus y squared.
Very good. 1 plus y squared. Then tangent AX will just be 1. Oh, so you are done with this answer. Okay? Secant square then this is 1 plus y squared. Okay? So maybe for the last 3 minutes of the lesson, just take some time to upload the practice set. Okay, I'll continue the rest. They are all the videos for practice set 3 are all inside. Like this one, right? You see, the videos are inside. The videos are online, so you can watch. Okay. Okay. Yeah. So this one also online. You can watch. Yeah. So I haven't do it. Okay, ma? So in the last 1-2 minutes, you just come in to upload. Then we will continue on Friday. Okay, have a good HDL. Alright. That's all. Thank you.